Write each expression as a single logarithm. So to take multiple logarithms and combine them into a single logarithm, we have some properties that we generally focus on. And those properties are that if you have two logarithms of the same base that are added, you can combine them into a single logarithm by multiplying their arguments. Or if they happen to be subtracted, you would divide their arguments. And if you have any constant multipliers, you can make those exponents on the argument of your logarithm. So using those properties, we can generally take multiple logarithms and combine them into a single statement. And this is an important property to be able to do for uh, solving logarithmic equations. All right, so the first one, we have log base a of x plus log base a of y minus log base a of m. So I have two logarithms that are added together and are of the same base, and that I can combine those into a single logarithm where the arguments are multiplied. So that's my first step. And then my next step in this process is to combine the remaining two logarithms, which are of the same base, into a single logarithm where the arguments are divided. And that's as simple as we can make that because we've got it into one single logarithm. For the next expression, we have log base a of m, and I'm going to put parentheses around that, minus log base a of n minus log base a of t. So the first thing, I have two logarithms that are subtracted. Since they're of the same base, I can combine them into a single logarithm where the arguments are divided by one another. Okay, and then the next step here is to do the same. I have, again, two logarithms of the same base that are divided, or subtracted, so I can combine them into a single logarithm whose arguments are divided. Now, I could do this as like m over n divided by t, but I think there's probably a better way of reducing that. So if I had something like m over n divided by t, then instead let's think of it as m over n divided by t over 1, because any value divided by 1 is itself. And we never actually divide fractions. Instead, we multiply by the inverse. So the inverse of t over 1 is 1 over t. So this would reduce to m over n times t. So that would be a better way of expressing the final answer. So we'll say this is log base a of m over n times t. And in the last expression, 2 log base a of z plus 1 plus log base a of 3z plus 2. In order to combine these into a single logarithm, the first thing that I can do is take this constant multiplier and make that an exponent on the argument of the logarithm. So this would look like log base a of z plus 1 to the second power plus log base a of 3z plus 2. Now that I have two logarithms of the same base that are added together, I can combine those into a single logarithm where the arguments are multiplied. And it's not really necessary to expand these polynomials out. That's not really going to make the expression any simpler. The simplest form is generally considered to be the factored form of a polynomial anyway, so we'll just leave this as is.